going to be working with now is x sine of x. So I'm going to go ahead and type that into my y1. Make sure that you're also in radian mode. In this class, we're always in radian mode. So double check that you're in radian, which I am. And what I want to be able to do is look at this graph and also look at the graph of the derivative. Okay, so let's just take a look at this graph real quick. So this is what this graph looks like, x sine of x. And let's just set our window from -4 to 4. So let's just look at this portion of the graph. Okay, a couple things I want you to think about is notice that there are 3 places where there is a horizontal tangent, right? Where there's that little peak up here, the little valley here, and another peak. So in this window that I'm showing, it looks like there are 3 places where you have a horizontal tangent. And we want to start thinking about what is the slope of a horizontal tangent line. The slope is 0 there. Okay, so what I'm going to do is I want to look at the graph of the derivative of this entire graph at the same time. So we don't know how to graph this derivative yet, but I'm going to have the calculator do it. So we're going to go to math, and if you remember in the previous problem, it's going to be number 8. So we're going to take the derivative with respect to x. My equation's in y1, so vars, y vars, function. Tell the calculator to take the equation that I've typed into y1, and this time I want the entire graph of the derivative. Okay, and let's go ahead and graph it. Oops, actually, I'm going to do something else. I'm going to go back to my y equals. Notice if I graph it like this, it becomes very hard to tell which one's the original graph, which one's the derivative graph. So what I'm going to do is go back to your y equals screen, and if you have a color calculator, it's even better, but if you go all the way to the left, I'm going to go ahead and press enter, so the derivative graph is going to be the bolded one, so I know which one is which. So let's go ahead and look at the graph again. So here's the original graph. Here is the derivative graph. And let's talk about what we just talked about the horizontal tangent. So remember we said on the original graph there were 3 places where it looked like there was a horizontal tangent. Right up there, right, there is a peak. I can draw a little tangent line that's straight across there. And notice the derivative graph has a y value of 0 because the slope at that point is exactly 0. Notice that x equals 0, which is a little valley. Okay, so we said that there's a horizontal tangent there. That is also 0. And then notice this peak here, there's another horizontal tangent we could draw right there. And notice the value of the derivative is 0 there. So that's the first piece. Can you try to figure out where the derivative is equal to 0? Now let's look at one other piece on this graph. Okay, let's look on the original graph where the graph is increasing. So I would say from here, it looks like -4 up to this peak here, the original graph is increasing. So if you draw a tangent line anywhere along this portion of the graph, that line has a positive slope. So notice your derivative graph, all the y values are positive. From here to 0, notice the original graph is decreasing. So if I draw a tangent line there, all the slopes are negative. So notice here, all those y values are negative. And then you can also see that same idea on the right side of the graph.